Last but not least, we have this exercise. Jenny has a circular cylinder with a lid. The cylinder has height 39 centimeters and diameter of 65 millimeters. Notice in the problem, millimeters is in bold because they want you to understand we're not working with the same units. That means that we're going to have to convert. Calculate the volume of the cylinder in cubic centimeters. Give your answer correct to 2 decimal places. Okay, volume of a cylinder. If you were to find your formula packet or the formula anywhere on the internet, the volume of a cylinder is basically just pi radius squared times the height. They haven't given us the radius, they gave us the diameter, but they gave it to us in millimeters. So I don't know if you've ever heard of King Henry died Monday drinking chocolate milk. I know it might seem a little silly. Here, this is centi and this is milli. So we have kilo, hecto, and deca. And this is your main unit, meter, liter, grams. It works for all of them. And this is deci. And the reason why we have this is because it helps us figure out which way to move the decimal point. Right now, I'm going from milliliters back to centimeters, which means that I'm going to take the decimal point. There is none, which means it is understood to be after the 5, and I'm going to move it back 1 decimal place. So then 65 millimeters is going to be the same as 6.5 centimeters. And most of you, I mean, this is an easy conversion. You basically know that you're just going to have to divide by 10. But in case you have a hard time with conversions, I find this to be such an easy way for you to remember which way to move the decimal point. So King Henry died Monday drinking chocolate milk. A little morbid, I have to admit, but at least it does the job. So from this case, I know that here the diameter is going to be 6.5 centimeters. So the radius is going to be half of 6.5, which is 3.25 centimeters. I can go back now to my volume formula, and the volume is going to be pi times the radius, which is 3.25, squared times the height, which is 39. So there is a pi button in your calculator. Find it. Remember that pi is an irrational number, that is a decimal that continues forever and ever. It is not repeating. It's approximately 3.14, but it just keeps on going. So it's always best to use the actual pi button from the calculator, which has the entire number stored. So we're going to put pi times 3.25 squared times the height of 39. So we get an answer of 1294.139. So about 14. And this is going to be in cubic centimeters. If you're studying for the IB exam, you know that for the IB exam, unless they tell you otherwise, you would have to round to 3 significant figures. In this case, they do tell me that you want the answer correct to 2 decimal places, which is exactly what we have done. We have written the answer with 2 decimal places. So this is correct. Then the problem continues. The cylinder is used for storing tennis balls. Each ball has a radius of 3.25 centimeters. Calculate how many balls Jenny can fit in the cylinder if it is filled to the top. I don't know how much experience you have with tennis balls in a container, but think of the fact that they are stacked one on top of the other. Okay, so they tell you that each tennis ball, which they're supposed to be the same size, in my drawing they're not, they're packed into these like containers where they fit nicely. You're trying to figure out how many are going to fit. The radius of one ball is 3.25, which means that the diameter is going to have to be double. So the diameter is going to be 6.5. So each ball, like the height of each ball, is 6.5. If I know the total height of this container is going to be 39 centimeters, then I can take 39 and I can divide it by 6.5 to find out how many balls are going to fit. And when you divide, you get 6. So the answer is 6 balls. Jenny fills the cylinder with the number of balls found in part B, so 6 of them, and puts the lid on. Calculate the volume of air inside the cylinder and the spaces between the tennis balls. Convert your answer to part C, part 1 into cubic meters. Okay, so basically you have this container. We decided that we're going to have 6 balls in here, so we're actually missing 2 more balls. So now we have 6, 1, 2, 3, 4, 5, 6. And it's in this container that's going to have a lid. So there's going to be spaces. All of these spaces here in red are going to represent the amount of space that's basically air in between where the balls are and the container. Okay, so our job is to figure out the total volume of air inside of this container. So how do we do that? Why don't we take the total volume of the entire container, which we found in part A, if you remember, we did find that already, and let's find the volume of 1 ball. Let's go ahead and multiply that by 6. So the volume of a sphere, because that's what a ball is 4/3 pi radius cubed, which in this case is 4/3 pi. The radius is 3.25 cubed. So go ahead, go to your calculator, and we're going to do 4/3 times pi times 3.25 to the 3rd power. That's going to give me 143.79,33137. I'm going to multiply this, which is about 144 approximately, times 6, because there are 6 balls that are in here. Even though I'm writing 144, which is rounded on my work, in the calculator, keep the 143.79,33137. And then just multiply that value by 6, and you're going to get 862.759. So I'm going to take the total volume of the container, which is 1294.14, and I'm going to subtract the total volume of those 6 balls. I'm going to round this to 2 decimal places, just like the previous answer. And then I'm going to figure out this difference, 1294.14 minus 862.76. I get 431.38. And so all of these measurements right now are in cubic centimeters. Okay? Are in cubic centimeters. So the answer to part 1 is going to be 431.38 cubic centimeters. Now, part 2 says that you want to convert your answer into cubic meters. So how am I going to convert this into cubic meters? I need a little bit of space. I'm going to erase what I have so far. In doing the conversions, King Henry died Monday drinking chocolate milk. This is our main unit, meter, liters, gram. We have deci, centi, milli, and we're going from centimeters to meters. So centimeters to meters, I have to go back 2 spaces. Basically, I have to divide by 100. 1 meter is equal to 100 centimeters. 1 cubic meter is equal to 100 cubed cubic centimeters. So this means that 1 cubic meter is equal to 1 million cubic centimeters. So basically this means that if I'm going from centi to meters by going back 2 spaces, because I'm going from cubic centimeters to cubic meters, I'm going to have to go back 2, 4, 6 times. So let's go ahead and take our number. which we got 431.38. And let's move the decimal point back 6 spaces. 1, 2, 3, 4, 5, 6. So here's my decimal point, and I'm going to fill these in with zeros. So my answer is 0.000431. We can leave it at 431 for 3 significant figures, or we can keep writing the 38. And so the units here are going to be cubic meters. If they were to ask you to write this in scientific notation, which they haven't, but if they did, then you can only have one decimal place in front of the decimal point, like only one number in front of the decimal point that's not 0. So then it would be 4.3138 times 10 to the negative 4th power. And that's only if they were to ask you to write the answer in scientific notation, or perhaps you prefer to write the answer in scientific notation. But here you go. We have finally answered all of these problems. This one was particularly interesting, especially because it has a mixture of, you have to find the volume, you have to find conversions. So there was a lot of good things that were happening in this problem. I hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.